this video, we're going to name and draw a variety of amines and also classify them as being either primary, secondary, or tertiary. So here we have an amine. The longest chain with the amine group is this 2-carbon chain over here. So we know we have an ethanamine molecule where the nitrogen is on carbon number 1. But we have a substituent on the nitrogen. We have a methyl group. So we have an N-methyl and then ethanamine. This nitrogen has 2 carbon chains on it, so we know it's a secondary amine. Pentan-2-amine. Pent meaning 5, so we have 1, 2, 3, 4, 5. And on carbon number 2, 1, 2, 3, 4, 5, we have our amino group, which is the NH2 when there's nothing else connected to it. You could also do this, 1, 2, 3, 4, 5, H3, then we have an NH2 over here, an H, H2, H2, H3. Pentan-2-amine. Okay, so here we have an amine again. This time we have 2 substituents, but our parent chain is over here. Our parent chain looks like a cyclopentane molecule. So we're going to have a cyclopentanamine. But first we have to list our substituents, and we have 2 on the end. So we have N, dimethyl, cyclopentanamine. Okay, next we have our N-diethylheptan-3-amine. So we have 7 carbons, and our nitrogen is on carbon number 3. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So we have our nitrogen over here. And then we have ethyl on the nitrogens, 2 of them. So 1, 2, and then 1, 2. And so there we have our N-diethylheptan-3-amine. You can also draw it like this. So 7 carbons, that's 3, 4, 5, 6, 7. We have on carbon number 3, 1, 2, 3, a nitrogen with a methyl, CH2, CH3, and then another one over here, CH2, CH3. We can go ahead and put in our H's everywhere else, H2, 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 H, H2, H3. And there we have it, our N-diethylheptan-3-amine. Okay, so next we have to find our longest chain that contains the N. It looks like it's going to be this one over here. So at this point, we've done a lot of examples, so you should pause the video and try it yourself. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's a pentanamine, but the nitrogen is on carbon number 1, 2, 3. Doesn't matter which direction you go. So what do we have here? We have our, methyls. We have N, then 3 trimethyl, and then pentan-3-amine. All right. Oh, and we forgot to classify the other amines as either secondary, primary, or tertiary. So this one here, only attached to 1 carbon chain, primary. This one here, tertiary, because it's attached to 1, 2, 3 carbon chains. This one here, attached to 1, 2, 3 carbon chains, so also tertiary. This one here, attached to 1, 2, 3 carbon chains, so also tertiary. This one attached to 1, 2, 3 carbon chains, so tertiary as well. We can go ahead and name this. So we have an N-dimethyl. And then we have 1, 2, 3, 4, 1, 2, 3, 4, butanamine. Next, we're going to try to name draw the N-ethyl N-methyl benzanamine. Or benzamine. So let's draw a benzene molecule like this. We'll put our N over here because it's carbon number 1. And we have an N-ethyl. So 1, 2, and then an N-methyl. And there we have it, N-ethyl N-methyl benzamine. And so that consisted of a variety of practice problems where we had to name and draw amines and also classify them as being primary, secondary, or tertiary. As you can see, this one here has 3 carbon chains connected to it, so this is also a tertiary example. It's important to understand the properties of amines, and so you can take a look at some data provided here. With the data provided, we can see roughly where amines fall relative to hydrocarbons and alcohols. So if you look at comparable ones within the same row here, we can see that hydrocarbons have the lowest boiling points, whereas alcohols have the highest, and amines are somewhere in between. And you can see that's the case for all of these situations here. And yes, amines can hydrogen bond like alcohols. However, and that's why they have a higher boiling point than hydrocarbons, but the NH bonds is not as polar as the OH bonds. So their hydrogen bonds are weaker than that of alcohols, which is why they have lower boiling points or melting points than alcohols. They are capable of hydrogen bonding to water, so they are soluble in water. Generally speaking, there's less hydrogen bonding as you go from primary, secondary, tertiary. And it makes sense. If you look at the data here, take a look. So boiling point, 35, 49, 3.5, negative 0.5. So if you look at the amines themselves, okay, so this is not an amine, this is simply a hydrocarbon with a hydrogen. This has a very low boiling point. As soon as you go to get an amine now, you have a much higher boiling point, 49, and that's because of this hydrogen bonding that's possible. But now if you replace the H by a carbon chain, you have less hydrogen bonding, and that makes sense. You can see that in your boiling point, it's much lower. And you replace one of the H's here with another carbon chain. So just take this off and put the CH3 there instead. Now we have an even lower boiling point than before, and that's because you've removed the ability of this molecule to do its hydrogen bonding, and so that's why its boiling point is lower. Notice though it's not the LDF because these are very similar in mass. We simply took this and put this over here, and then here we took this and put this over here. So they were basically similar mass to each other. As a result, it's really not the LDF at fault here. It's more so the fact that we have primary, secondary, or tertiary with less hydrogen bonding. So tertiary has less hydrogen bonding than secondary or primary, which is why they have lower boiling points in general for those of comparable size. In the next video, we're going to take a look at amides. We'll do the same approach. We'll learn what amides are, see their functional group, learn how to name them, learn how they're made, learn how to draw them, and then we're going to take a look at their properties.